This is example 2 of the logarithmic functions lab in part 2. In part 1 we had f of x equals log of base 1/2 x plus 30 minus 4, and we found out how we transformed to get this function from the more basic function of f of x equals log to the base of 1/2 of x. We found that there were no reflections, that there was a horizontal shift to the left 30 spaces, and that there was a vertical shift down 4 spaces. For part 2, I want to find some key information about this function, such as its domain, its range, whether it's increasing or decreasing, if it has x-intercepts and y-intercepts and what are they, and whether it has any asymptotes. So we're going to go back to our graph to find out the domain. So here's our graph. The red is the more basic function of log of base 1/2 of x, and our graph in black is our transformed function. We see that in our original graph we had a domain of 0 to infinity. There's a vertical asymptote at 0. When we move this function to the left 30 spaces, that vertical asymptote also moves with it, and so our domain has changed from 0 to infinity to negative 30 to infinity. So writing that down, our domain is negative 30, not including 30, to infinity. Next we'll look at our range. So for our range, we can see that in our original function, it goes from negative infinity to positive infinity. This may look like a horizontal asymptote, but it is in fact not. It's simply decreasing very slowly. And this remains the same for our transformed function. So our range, our y values, go from negative infinity to positive infinity. So writing that down, we go from negative infinity to positive infinity. Now we need to look at whether it's increasing or decreasing. We see that both our original function and our transformed function are going downward, so they are both decreasing. So our transformed function is decreasing. We're going to look at x and y intercepts. We do have x and y intercepts. So for our x-intercept, we have this value right here at negative 29.9380. And for our y-intercept, we have 0, negative 8.907. We can solve for those algebraically, and I will as soon as we look at our last item on the list here, which is asymptotes. So if we look at our asymptotes, we see that we have, in fact I already mentioned, we have a vertical asymptote that moved when we transformed the function to the left 30 spaces. So we have a vertical asymptote at x equals negative 30. So for asymptotes, there is a vertical asymptote at x equals negative 30. So now we're going to look at our x and y intercepts. We already found them graphically, but we want to find them also algebraically in case we don't have access to a graph. So the way we're going to do that is we're going to first look at our x-intercept. And our x-intercept is when our y is equal to 0. So looking at our function again, we're going to substitute f of x for y. And so we're going to substitute f of x for 0. So we're going to write 0 is equal to log of base 1/2 of x plus 30 minus 4. And now we need to solve for x. So we're going to add 4 to both sides. So 4 equals log of base 1/2 x plus 30. And now to get our x alone, we need to remember what logarithms mean. So logarithms essentially have a formulaic response. So if we have a log of base n and m is equal to x, this is equivalent meaning of n to the x is equal to m. So using this equivalency, we see that our n here is 1/2. So we can rewrite this whole thing as 1/2. And our x here is 4. So our x is 4, so it's 1/2 to the 4 is equal to our m, and our m is x plus 30. So we have 1/2 to the 4th equals x plus 30. 1/2 to the 4th is 1/16. And then we're going to subtract 30 on both sides to get this x alone. So you have 1/16 minus 30 is equal to x. We can put that in a calculator and we'll find that x is about negative 29.938. Or we can write this in fraction form, which I'll demonstrate for you if you need a refresher. So we have no base here for 30, so we'll have to multiply, we have to get the same bases, same denominator on the bottom here. So we'll have 1/16 minus something, the denominator has to be 16, and 30 needs to be multiplied by 16 to get that. And so what that'll be is 479. So 30 times 16 is 480, excuse me, 480 over 16. So now that they have the same base, we can subtract. So 1 minus 480 is negative 479. Divided by 16 is equal to x. And those are equivalent. So our x-intercept is negative 29.938. Remember, we have to write it in point form. So we can actually write that over here. Our x-intercept is negative 29.9380. And then moving on to our y-intercept, we saw that graphically as well. But if we want to find that algebraically, if we don't have access to a graph, we can remember that for y-intercept, our x is equal to 0. And so having our function here and using y for f of x, we can write y is equal to log base 1/2, and x is 0, so it's just 30 minus 4. And if we put this into a calculator, we get y is equal to negative 8.9069. And so what this means is that we have a y-intercept at the point 0, negative 8.9069. And we can write that over here. And we have discovered all of the key information about this function.